But no, I personally really like these questions because you get to think about them a little bit, and it's nice, right? Okay, so here, let me see. Let me start up the poll and let's work on this one. How many hands of 5 cards contain exactly 1 heart and 1 jack? Also, by the way, if you're someone who doesn't know what a standard deck is, that's okay. But like, just let me know in the comments. You can direct message me if you want and just be like, hey, I don't. Okay, sure. So a standard, see, this is always an interesting thing to me because like, I always wonder how this ends up happening. Not that it would be any fault of yours, just like maybe it's not frequently used in different parts of the world. So standard deck, why can't I write, annotate? Okay, so a standard deck, that's a weird colored. So it has ranks are ace, 2, 3, 4, 5, 6, 7, 8, 9, 10, jack, queen, king. Okay, the ranks aren't important. Right, okay. So for this question, the ranks, yeah, that's what a standard deck is. And then the suits are, okay, now I have to try and draw stuff. Hearts, diamonds, clubs, oh no. That's my club. And spade, also, oh no. Okay, those are my things. No jokers. Yeah, a standard deck does not have jokers. So therefore, there are a total of 52 cards, right? So there are 4 times 13 equals 52 cards. Okay, now as a general rule, we don't use these sorts of questions on a test just because it does kind of require that you know what a standard deck is. That being said, don't quote me on that just because now that it, like if it were in person, it would be different. But online, you can always just look up what the standard deck is, right? But yeah, this is a standard deck. We have encountered plenty of students in the past who've never, handled one of these things. Yeah, I did too. But yeah, Brandon, we find that there are definitely students who have never heard of them. So yeah, I don't know. Sure. Yeah. Yep. Now we know standard deck. Which is just, again, it's different from like if you include jokers, right? If you include jokers, it's not a standard deck anymore. So standard deck is explicitly like don't include jokers. Okay, what is it? I'm always interested to know. Like, is it called different? Does it have different ranks?
I think they're trying to say it has a different name. It's not called a standard deck.
Yeah. So what is it? What is it called? What is its name then? Or a translate of it, or a direct, right? Or whatever. It's always interesting to know. Okay. Just called a set of cards. Sure. Sure. Yeah. I can't remember. There's also, I have like an old Japanese deck. I don't remember what they're called. The Hanafuka cards, I think. Oh, Hanafuda. Right. So I have a set of an authentic original set of one of these. And then, so here's the interesting thing, right? Like, so one of my best friends is married to a Japanese girl, like Japanese, right? Like from Japan. And so she was going back to Japan. She's like, hey, is there anything you or your family want? Right? Because we are ancestrally Japanese. And we're like, hey, yeah, like, you know, grab a set of Hanafuda cards. She was like, no, I refuse. And I guess that there's like a fairly big affiliation between Hanafuda cards and the Yakuza. So she was like, yeah, I'm not going anywhere near that stuff. But, you know, we didn't know because we're so kind of removed from Japan. So anyway, it was kind of an interesting thing. What's what? The Yakuza? The Japanese mafia. Mm-hmm. Okay, we're almost at 7 minutes, so I'm going to call it in about 30 seconds here. Man, not too many people want to answer this one. And a lot of people don't know what the answer is. That's okay. That's okay. This is how we learn. This is how we learn. Okay. You know what? Again, some part of me kind of, you know, some part of me is kind of sad when the answers come like this, but some part of me is kind of happy because it means that like we have an opportunity to do some like cool learning, right? Like we're going to see how exactly this works. Let me just clear off these annotations here, clear the drawings. All right, and let's switch. Whoa, why are you still annotating? Go away. Okay. All right, which question is this? This is question 9. Okay, so we've got just a set of cards, standard deck. We want exactly 1 heart and 1 jack, right? So we want exactly 1 heart and 1 jack. Okay. So yeah, let's count this. And I think sort of the best way to do this is, I think, is there any way for me to naturally lead you to this answer? It's a little bit tricky. Basically, we have to break this into cases. And the reason for that is that there's one card that is really a pain in the butt. And what card is going to be a pain in our butt? Can anyone think? The Jack of Hearts, exactly. Because the Jack of Hearts is both a Jack and a heart, right? So it counts as both. So what we want to do is we want to break it into cases where we have the Jack of Hearts and the case where we don't have the Jack of Hearts, okay? So let's do case 1. So let's suppose our hand has the Jack of Hearts. Has the J heart. Okay, so this means we're done, right? We have all the jacks that we need and we have all the hearts that we need. So all we need to do is choose the other 4 cards, right? So we have our jacks, we have our jack, and we also have our heart. So we just need the other 4 cards. Okay, but importantly, the other 4 cards cannot be jacks, right? None of them can be jacks and none of them can be hearts because we're only, like the question says exactly 1 heart and 1 jack, right? Not at least 1, exactly 1. So none of the remaining 4 cards can be a jack or a heart. So if I remove all the jacks from the deck and all the hearts from the deck, how many cards are left over? Are not jacks or hearts. Right. So Brandon, exactly. 36. Does everyone agree? There are 36 cards that are not jacks or hearts. Is everyone okay with that? Okay, wait, Aiden, so you're getting a little ahead for choosing a jack. Well, okay, so that's the next case, right, that you're thinking of? I think maybe. Right, but so 36 is the number that have, or the number, no, it's okay. So there are 36 is the number of cards that are not a jack and not a heart, right? Yeah, exactly, Namir. 52 minus 13 minus 3. Now, why is it only minus 3? This is the important point, everyone, because you might be tempted to do 52 minus 13 minus 4, right? 13 for the hearts and 4 for the jacks. But exactly, we already have, like when you take one of the hearts out, you've already taken the jack of hearts, right? So you only need to take out now the jack of spades, jack of diamonds, and the jack of clubs, right? So there's 36 cards in your hand that are not jacks or hearts. So how many ways are there to choose the last 4 cards from the 36 cards that you have left? 36, choose 4. Right, okay. So case 1, here's our answer. So if you have the jack of hearts, because there's only one way of choosing the jack of hearts, right? Okay, so I have a direct match that says, shouldn't it be minus 12 since there's a jack of hearts? It depends what you mean, like minus 12 where? Or you could say minus 12. You could do 52 if you want, minus 12 minus 4 if you want. So this is removing all the hearts that aren't the jack of hearts, and then this is removing all the jacks. But it doesn't matter. You get the same answer as if you did 52 minus 13 minus 3. Right? Minus 12. No, it depends because, well, again, the jack of hearts isn't. So the follow-up question was, shouldn't it be 52 minus 12 minus 3? No, we've already removed the jack of hearts. It's true, like that is remaining, in which case this would be 51, right? Because we've already taken the jack of hearts out, right? So now there's only 51 cards remaining. That would also give you the same answer. Yeah. Okay, so it just depends on where you put the jack of hearts. So if you include all the cards and you remove them when you remove the jacks, you would have the 4 there. If you remove them when you remove the hearts, you would put it there. And if you just say, oh, we've already done the jack of hearts, so there's 51 cards remaining, you would put it there, right? They all work out to give you the same answer, but it's just where did you include the jack of hearts? Okay, so that's case 1. Now case 2. Okay, so there's no jack of hearts. You're not allowed to use the jack of hearts. Okay, so let's start off. How many ways are there of choosing a jack that is not the jack of hearts? Ah, right. So 3, choose 1, or Brandon, that's the same thing as just 3, right? Because like how many jacks are there? There's 3 of them, right? And a person who direct messaged me, not 4, because it would be 4 if we said how many ways are there to choose a jack, but remember we're saying none of them can be the jack of hearts, right? So we're going to take one of them out. That's okay? Okay, so this one is hearts, but not the jack of hearts. So how many ways are there of doing this? Yeah, perfect, 12. Okay, now our last 3 cards, which again can be anything. So I remember not the jack of hearts. So there's 13 hearts, but because we can't do the jack, we have to take that one out, right? So that's why we get 12. So I got a direct message that says, so there's 3 jacks and 1 jack of hearts. Exactly. Yeah. There's the jack of hearts, jack of diamonds, jack of spades, and jack of clubs. Yeah. Okay. Now these last 3, okay, again, so we've already got our jack, we've already got our hearts. So these again have to be non-jack, non-heart cards, right? So we've got 3 cards here. None of them can be jack. So non-jack and non-hearts. So how many ways are there to choose these 3? 36, choose 3, exactly. right? Because again, just like the previous question, exactly everyone, nice job. We have 36 cards that are not jack and not hearts by the exact same computation above. We need to pick 3 of them. So that's 36, choose 3. So this is our answer, right? We would multiply these together, and that's the answer for this case. And then we're going to add them up, right? So the total is therefore the sum of these two. So that's going to be 3 times 12 times 36, choose 3, plus 36, choose 4. Okay, that was B. Does that make sense? And hopefully it's clear like why you had to break that into cases in order to account for the jack of hearts. I think a lot of people said C. Here, let me show you what the answers were. Okay, so I think a lot of people said C because they didn't account for the jack of hearts. But just keep that in mind. Like if you do 13 and then you do 4, you potentially counted the jack of hearts twice, right? Because the jack of hearts is in that 13. And if you choose the jack of hearts there, well, you know, that you're done. Like you don't need to choose another heart. And so that 4 is no longer correct. So we have to be a little bit careful about the jack of hearts. It's just that tricky thing. Exactly. The jack of hearts is making it confusing. Yeah. Right. Because you have to treat it as a separate case because it overlaps, right? It is both a jack and a heart. And that's what makes it tricky. Right. So you have to be a little bit careful about that. Right. So yeah, that's the idea. So are there any more questions about that? I can go back to the other screen too if anybody needs to look at that. In case 1, are we counting the jack of hearts as 1? What do you mean as 1? So it's a single card, but we're counting it as both a jack and a heart. Does that make sense? Because it is a jack, right? And it is a heart. Exactly, yeah. So there's only one way to choose the jack of heart. And so there's like, really, there's a 1 hanging out in front of that number, right? It's kind of like there's a 1 here times that number. And that 1 corresponds to how many ways is there to choose the jack of hearts? There's only 1 of them. So that, right, that's where that 1 times it comes in, 1 times 36, choose 4. But, you know, we kind of dropped the 1 because we, you know, we're not worried about it. We know it's there. Right? Anytime where you don't get a choice, if you don't get a choice, the number is 1, right? Because there's only one way to choose it because you don't get to choose it. Right? And that's an important thing that is going to come up on this assignment that's due tomorrow, right? Is if you don't get to choose it, there's only one way to choose it, right? It's forced on you. You don't get to do any variation. That's an important thing that's going to come up on that assignment. Okay. Let's see, what was the next one I want to do? Oh, I'm going to skip 10 and I'm going to go to 11. Yeah. So same question. Not same question, similar question. So 3-card hand this time, not 5-card. It's okay. It's true in the sense that like having played cards might help a little bit, but you just need to know again that there are, you know, 4 suits and 13 rings. And as long as you know those things are true, I promise you that there isn't like anything crazy where, you know, if you play a ton of poker, if you're a card shark, then, you know, you're going to do these questions better. I promise you we could take professional poker players, ask them these questions, and you would do better, right? That like somehow that didn't really give them that much of an advantage. Other than maybe your ability to visualize the deck, right? Yeah, actually, when we were as instructors, when we were talking about these questions, you know, we were talking again about how some people haven't really seen a deck of cards or haven't played with a deck of cards. And I say, this is always so weird for me, just I guess because I had maybe a bit of a weird upbringing, but I was like raised and taught how to gamble, right? Like my mom's side of the family, are serious gamblers, like not, not crippling gambling addiction sort of thing, but will go to Vegas or Reno on occasion and usually come back winners. And so as a young child, I was taught the table manners of gambling, right? Like you would get yelled at if you did something stupid, especially in a game where your choices affected other people. Like if any of you have ever played blackjack, I guess most of you are probably too young to really gamble seriously. Yeah, it's fun, but obviously you have to be careful, right? But if you've ever played blackjack at a table, if one person does something stupid, it screws up the deal for everyone else, right? So like there is behavior and conduct and etiquette in playing some of these games. Poker is just a lot of fun too. Like even if there's no money involved, just get together with some friends and play, and it can be a lot of fun, right? It's a lot of fun. That's okay too. And I mean, like gambling is like drugs, right? Some people can handle them okay and can do things recreationally like alcohol, but alcohol can also ruin lives, right? And gambling is very similar. And I think you have to have a view of gambling that it's purely entertainment. It's not isn't something you should try and use to be your lifestyle, right? Your livelihood. But like anything, if you do it responsibly and you do it safely, it's fun and it's entertaining. But like if but no, nobody has to do it, right? It's not required. Yeah, and I mean that happens, right? There are definitely people out there who, gamble like and have addictions, and those people just need to just stay away from that stuff, and that's totally okay. That's cool. Yeah, I haven't drank in 3 years, right? I used to be quite the drinker, but I quit 3 years ago. Yeah.
You quit? I did not know that.
Yeah, I quit.
Interesting.
I haven't drank at all in 3 years. Yeah, actually, I'm trying to remember like I think it was December 2018. So it's almost been exactly 3 years.
I remember we went to the UTM pub once for lunch.
Yeah, I took all UTAs out.
Yeah, and I remember you grabbed a pint at the time, so that's why.
Yeah.
Interesting.
Yeah, December 8th, 2018 is the last time I drank. Yeah, and that's fine too, right? There's nothing wrong with that. I mean, like I used to drink a lot of scotch, right? Because that was my big thing. And then like red wine, and then it was red wine, scotch, and then what was the other big one? But yeah, so I've got this beautiful, beautiful liquor cabinet of just really expensive scotches that I just haven't been touched. So I try and get rid of them every time someone comes over and try and pawn my scotch off on them. Yeah, like my favorite used to be the Lagavulin 16, like just phenomenal. And it's a pretty expensive bottle too, but like, yeah, exactly. There's a lot of people. This class has a lot of people who are actually pretty young, right? So for whom you can't legally drink yet. That's okay.
Oh, happy birthday!
Yeah, happy birthday. It's legal in Alberta, but when you come to Ontario,
and Quebec, I think as well.
Yeah, and Quebec. Yeah, but in Ontario it's 19. So. Yeah, but also, everyone, it's like anything, don't start it. You never have to quit it. Right? It's one of those.
Very fair. I do gamble quite a bit, but I enjoy it. I do it more for fun, not because I kind of like need to gamble. More do I do it because I think it's fun.
Yeah.
Mm-hmm.
Sorry, you go.
No, I was just saying I pick my poison. It's always poker. It's Texas Hold'em.
Oh yeah. Yeah. Even so, when I was raised in poker, right? Because everyone nowadays plays Texas Hold'em. When I was raised in poker, though, it was always dealer's choice. Okay. And that's a mess, right? If you ever played it, because you need to know like 30 different versions of poker. So I guess nobody does that anymore because it's it's crazy. But like between Fiery Cross and baseball, and then just standard 5-card draw, 7-card stud. And then doing all sorts of like crazy. I remember doing all sorts of like crazy wild cards. Like, do you know like what Kings and Little Ones is?
I've never heard of that.
Yeah,
the other ones I've heard of, but this one I've never heard of.
Okay, so you play like 5-card stud. You can do like 3 draws of 3. Kings and little ones are wild. And so what kings and little ones are is kings are wild, and whatever the lowest suit in your hand is wild, or the lowest rank in your hand. Right?
Interesting.
So if
Okay.
you have, if you have like 2 2s and they're the lowest thing in, or 2 3s and they're the lowest thing in your hand, they're both wild. But the moment you pick up 2, they're not wild.
They're gone. Yeah.
Yeah.
Very interesting.
How hard is it to learn poker? Depends on the poker. Like, do Texas Hold'em, and it's as straightforward as it comes.
Texas Hold'em it's easy to learn, but hard to master. That's kind of like the best way.
Yeah.
To say about Texas Hold'em.
Yeah, if you're gonna learn, that's probably the place to learn. I'm gonna close it in about 30 seconds, everyone. So get your votes in. The main thing, Gerper Tap, is just knowing like what the hands are and what their ranking is. And I think that's like, start by understanding that and then get into the lingo, right? What is the flop? What's the turn? What's the river? Learn how to like count outs or whatever they're called. But like, if you're just playing for fun, you're not playing for money, just go and play for a bit and you'll figure it out, right?
Yeah, agreed.
I think
I used to play Niagara Falls before they closed down tables.
Nice.
But they haven't opened since then.
Yeah, I'm sure they will shortly here. We're getting pretty good. Okay, so a lot of people said C and D. C and D are not correct. Believe it or not, the correct answer is A. So almost the one that was least said is the correct answer. Not quite. B was a little bit less. But yeah, C and D are not correct. And we can try and talk about that in a little bit if we want. But let's go through what the correct answer is. Now, this isn't one where I think you should try and count the hand directly. Okay, this is going to be a little bit nasty if you want to do at least 1 king or at least 1 heart. If you do it directly, it's a mess. Instead, it's a lot easier to count the complement. Okay, so count. So this one's question 11. Okay, so you want at least 1 king and at least 1 heart, or at least 1 heart. So at least 1 king, or, and the or here is important, right? Or at least 1 heart. Okay, now if you're wondering like, oh, well, why did they make us learn about those unions and intersections and things, right? So if we let something like, let K, capital K be the collection of hands such that there's a king in that hand. A king. And then we let H be the set of hands that have at least hands. So at least 1 heart. I guess I should say at least 1 king. Then we're looking for K union H. Does everyone agree? The number of hands that it contain at least 1 king or at least 1 heart, right? So we want the union of these 2 things. Now this is pretty hard. It turns out to actually compute this is pretty hard. So what we're going to do instead is we're going to compute its complement, which hopefully, if you've been kind of like thinking about your Venn diagrams, right, it would be the intersection, i.e. it's the set of hands such that those hands contains, actually, you tell me, if I were to describe the complement of K intersect the complement of H, what is that set as, like, in words? No kings and no hearts, exactly. Does everyone agree? Okay, if that doesn't make sense, you should say something, right? Because the complement of K contains no kings, complement of H contains no hearts. We want both of those things to be true because we took the intersection, so no kings and no hearts. Okay, how many cards are not kings and not hearts? Like how many, like if you just took a deck, you took out all the kings, you took out all the hearts, how many are left over? 36, exactly. Right? It's the exact same as the jack, right? Instead of throwing out the jacks, you threw away the kings. It's the same answer, right? So there are 36 cards that are not hearts or jacks. So if I need to make a 5-card hand from these cards, how many options are there? $36, choose 5. Exactly. Ways of choosing a hand with no hearts and no kings. Okay. Oh, is it? Oh, you're right. You're right. It is 3-card hands. You're absolutely right. Yeah, it's 3-card hands. You are absolutely correct. Thank you. Thank you, Jack, for reminding me of that. Yeah. Why did we have to show complement? I'll show you in a second. Yeah, sorry, everyone. I must have missed the chat. And I looked down for a second and you're all correcting me. But yeah, it's no kings, no hearts. It's a 3-card hand, so it's 36, choose 3. I have this direct message. It's supposed to be no hearts or kings instead of jacks. Did I say? Oh, yeah, I did write jacks here. Sorry, I'm kind of left over from the previous question. Okay. Now, how many 3-card hands are there total? $52, choose 3. Exactly. Right. And so the number that we're after, so K union H is equal to 52, choose 3 minus 36, choose 3. Right? Because this is all the cards, all hands. And these are the bad hands. Right? And so, yeah, Curtis, does that make sense about like, why did we do the complement? Because it was easier to count the bad hands than it was to count the good hands. So we're going to count the bad hands and then throw them out. Right? Yeah, exactly. Just like, when we did like, what was it, the postal code question? And you remember we said, oh, there were like 100 total of these answer, but there was one bad thing, so we threw it away. Sometimes it's easier to count the bad hands, the hands you don't want, and then you get rid of them. Okay. So in order to count, like you can see here, to count the number of ways that you have at least one king or at least one heart, if you try and do this directly, it's actually really, really complicated. Because sure, you can count the number of things that have at least one king, right? I believe you all could do that. And in fact, the best way to do that is still to take the complement. You could count the number of ways to get at least one heart. But the thing is, you can't just add those numbers together. Why not? Right, exactly, Agam. Yeah, the resulting hands will have at least one king or at least one heart. So why can't I just figure out the number of ways of doing at least one king and add it to the number of ways of doing at least one heart? What goes wrong if I do that? Okay, sure. Or another, maybe a slightly different way of putting it, Brandon, but I think you're on the right thing here, is that you're over counting your hands, right? Because here, let's say I say, okay, in the process of counting at least one king, right? Let's say I come up with this hand. So I come up with the king of hearts and then the 2 of hearts and the 3 of hearts, the 4 of, I don't know, diamonds, and the 10 of spades. Okay, so this is, I think you all agree, this is a hand that has at least one king in it, right? But then I go over, and I'm doing this separately. I'm going to count the number of hands that have at least one heart in it. And this is also valid over here. Do you agree? Copy. Oops, that is the wrong class. Okay, which is the copy button? Is this it? Paste. So does everyone agree that this is also a hand that has at least a heart in it? That it is a valid way in both? So I counted this hand twice. Does that make sense? Is everyone okay with that? Oh, you're right. I'm doing 5 card again. Yeah, thank you, Grouper Tap. Yep, you're 100% right. Let me get rid of those two. But Gerber Tap, very much thank you for pointing that out. I was again doing 5 card hands because that is my default. Either way, here are the 3 card hands. They're both counted twice, right? And this is an issue because these are the same hand. So I need to only count it once, but I've counted it twice. Right? And that's an issue. So if we were to try to do this directly without using the complement, what we'd have to do is we'd have to count the number of hands, right? We'd have to do the set that have at least 1 king, then add it to the set that has at least 1 heart, and then subtract the ones that have both a king and a heart. Right? And then add back in the king of hearts hands. So do you see that this is terrible? Like you don't want to do it this way? Right? Because you have to say what is the overlap between, yeah, exactly. What is the overlap between these 2 things so that I can say, oh, I counted all of those twice. I need to get rid of them. This way is way too complicated. You don't want to do it this way. Now, it's not going to work universally, everyone, but a good hint you can use for this is if you see the word at least or at most anywhere, that's usually a good sign that you should maybe look at the complement, right? It's not a guarantee, but if you see at least or at most, you should at least consider whether counting the complement is going to be easier, right? Because at least the words at least and at most have usually multiple cases in them, and maybe the complement has fewer cases. Does that make sense? All right, let me see what I want to do next. Oh, yes. Yes. For sure, this one. All right, this one.
Question.
Oh, yeah, this is one of my favorite questions.
I remember this question.
Yeah, I mean, you're in it.
Oh, yeah. See, guys, I'm kind of famous in this course.
Mm-hmm. Yes, there's lots of things named after Aziz. Okay, so I should say everyone here as well, because there just wasn't enough room to kind of put this in the question. So when you're doing this question, we're also saying that where you sit at the table doesn't matter, only who's beside you matters. Okay, so does that make sense? So what I'm saying is, if you see in the green here, if you took Ihsan, Jordan, Aziz, Parker, TJ, and Tyler, and you just shifted everyone over, you just rotated everyone clockwise. Exactly, yeah, Aziz and Ihsan can't sit together. So in the green thing though, yes, exactly. So if you take everyone at the green table and just make everyone move 1 seat clockwise, that is the same arrangement as far as this question is concerned. Does that make sense? Does everyone understand what I'm saying? Okay, so that is important. If you take the same configuration of people, then if you move them all down 1, that's the same configuration. If you move everyone down 2 chairs, that's the same configuration. So it doesn't matter where at the table they're sitting, only the order in which they're sitting, because that's going to change the answer.
Speaking of Ihsan, what courses is he teaching this semester?
He's got 247, 232,
Okay.
and like 102. I think those are it.
fair enough.
Yeah, JT is on sabbatical, so
Okay,
we
makes
gave
sense.
Ace on the specialist algebra classes.
I thought he just gave up on 133.
Yeah, it was one of those things that was like, yeah, he would have been fine doing it, but yeah, he had mixed feelings about the course. Do I teach 102? I did back in the day. Yeah.
I T8 102 as well a few times myself.
Yeah.
Back in
Yeah. So the thing about me is that my courses are pretty much fixed now, right? Like some people do a lot of service teaching where there's a coordinator for a class. So like, 102 has the same coordinator every year, 135 has the same coordinator every year, 133 has the same coordinator every year. And then you do service teaching, right? So TJ, for example, teaches 133, but he's also in charge of his own course. And so he goes and he teaches that course, but otherwise he service teaches, right? So he serves under another coordinator. I am the coordinator for all of my courses, which means I never do any service teaching, right? And because I'm the coordinator of those courses, those are the courses that I always teach and will always teach. So it's that sort of weird thing that I don't tend to move around in the department nearly as much just because I have my courses.
Mhm.
But yeah, I've taught 102 a couple times. It's a really fun course. I really enjoy teaching it.
I also said it was one of my favorite courses in university just because I took it my first year because I was debating doing a minor in math at the time. And that's the reason I continued my minor because I'm like, that was a fun course.
Yeah, it's a really cool course. Like if any of you get the chance to take it, I mean, obviously you kind of want to need to do more math. It is a fun course. You'll learn a lot. It'll really change. Nice. Okay, cool. Yeah. Nice, Brandon. But it's very different, right? I think like what a lot of us think of as being math and like what you all learned in high school is not real math, right? Like this stuff to an extent is not real math. And 102 is going to give you your first exposure to real math. And some people get freaked out by that.
I remember in one of the classes we walked in and Professor Shah Fuchs had like a big on the chalkboard. He had like big question. It was like, what's 1 + 1? And that's it. And obviously we're all coming in like brand new to this. So very defaultly said 2. Like he's like, I didn't define my field of elements and just changed the answer to 0.
Yeah.
And
yeah. If you're in Z2, the answer is definitely 0.
Yeah. So, and from that point onwards, I just was like, okay, this course is very interesting.
Yeah. I mean, it's the only other field in which that's true. But
exactly. Right. So yeah. So yeah, guys, 1 + 1 is 0, but don't do this in this course because I don't think I'll do.
It's 0 only in Z2, right? But you guys don't know what Z2 is, so don't use that.
Yeah, don't worry about it. I've seen that proof before. It's
yeah, that makes me angry. That one, like,
it's not real math.
Yeah, it's misrepresented as sort of like this nice thing that you can easily explain to the average person. Like, obviously, it can't be true, right? Because if you add up all these positive, or if you add up all these numbers, how do you get a fraction, and so on and so forth. But there's like something else going on behind the scenes that we kind of hide. There's I think cooler things that we can tell the story of that is not as disingenuous, right? So have I already asked you all like what the sizes of the naturals are and like the size of the integers and how many. We'll do that in a second. Let's do this question first, and then I'll hurt your minds.
Yeah, are you discussing the cardinality topic?
Yeah, exactly. Just show them the cardinality, and then I'll maybe do like Banach-Tarski.
Okay, fair enough. That's
what's fun. Aleph numbers or like Aleph, ALEPH? Is that what you mean? And 30 seconds, everyone. Yeah, Aleph, ALEPH. Yeah, so Aleph naught is the first count. Yeah, it's the first countable infinity. The problem is, of course, is that we don't know what Aleph 2 is. Or Aleph 1, rather, we don't know what Aleph 1 is. Which is a whole separate thing. Okay, let's take a look at this. Overwhelmingly, I really like to see this. The answer, most of the class said C. Yeah, the answer is 100% C, which is great job, everyone. Like, that's phenomenal. And so I'm hoping that like maybe something's getting through here. I hope that wasn't just like somehow statistically everyone was guessing. But yeah, no, that's great. I really like to see that. Okay, so this is question 12, in case you're looking for it later. So this is question 12. Okay, and again, I think what you all kind of figured out is one of the things that we want to do is we want to look at complements again, right? So what we want to do is figure out how many bad configurations are there, right? So let's count the complement. The complement, i.e. the number of configurations. So we said a good thing is where Ehsan and Aziz don't sit beside each other. So a bad thing is where they do sit beside each other, right? So the configurations where Aziz and Ehsan sit together. Okay. So the way that we're going to do this, does everyone, yeah, everyone luckily, oh no, we use TJ and Tyler. Okay, anyway, so we're going to treat Aziz and Ehsan. Let me just abbreviate them so I don't have to write out their whole names. We're going to treat them as a single unit. Okay, they're partnered together. And then we've got me, we've got TJ, we've got, who else was here? Parker and Jordan. Okay, so how many ways are there of configuring us around the table, assuming that we treat Ehsan and Aziz as a single unit, right? Like we said, they have to sit beside each other. So how many ways can we seat these things around the table? Anyone? 5 factorial, perfect. Ways to seat these units around the table. But that's not all of them, right? Yeah, exactly. Yeah, Curdy. Yeah, that's exactly right. Yeah, there's nothing wrong with that. Now, however, this isn't all of them, right? That's the number of ways to seat the units around the table, but that's not all the bad configurations. So what haven't we accounted for when we sat Aziz and Ehsan as a single unit? Right? So let's say I do something like Tyler and then TJ and then Jordan, and then Aziz and Ehsan are over here. And then we've got Parker over here. Yeah, they could swap places, the order that they sit, exactly. So we could have Ehsan and Aziz, and we have Aziz and Ehsan, right? So they could swap spots, and that would be a different configuration. So how do I fix the 5 factorial in order to account for that? Right? Exactly. We double it. Yeah, we multiply it by 2. Okay, so that gives us 2 times 5 factorial ways of arranging everyone around the table. Now, next up, we said it doesn't actually matter where at the table you sit, only the configuration that you sit in, right? So if I took everyone in this configuration and made them move over a seat, that would be the same configuration. So how many times did I overcount this configuration? Like how many different configurations are there of this? Curdy, yeah, that's the same thing. Yeah, your first answer. And if it, yes, and if it was 3 people, yeah, exactly, that's what it would be. It'd be 3 factorial. Edward, exactly, it's 5 times, right? Everyone agrees? Because you would take that group of people, and every single time you move everyone down a seat, that's the same configuration. So you say, well, how many times can I do this? before I get back to where I began? And the answer is 5 times, right? So there are 5, let's say, ways of sitting around the table. So we divide by 5 to get the total number of bad configurations. Right? So that gives us 2 times 5 factorial over 5. Okay. Now, what is so that was the bad configuration. So we need to subtract that from the total number of all configurations. And same sort of thing, what is the total number of configurations? Like, what is the total number of ways of sitting people around the table? At the 5th time a person reaches back to the position where it started. Exactly, Agam, right? So, and look at this picture and try and think about it. So if I moved, let's say, right? So if I move 1, I'm here. If I move 2, I'm there, then 3, then 4. So on the 5th time, I'm back where I started, right? So there's, I've overcounted 5 times, because for each one of this, where we're in this order, I've counted myself differently, whether I'm sitting on chair 1, chair 2, chair 3, chair 4, or chair 5. So I've counted that 5 times, depending on which chair I'm in. So I'm going to divide by 5 in order to remove that dependence. So does that make sense, Agam? Okay, cool. And then, yep, Sanam, there's 6 factorial ways to sit around the table. And again, we want to remove the order, right? We don't care like where you sit at the table, only the order. And so again, how many unique ways are there of like cyclically rotating us around the table? So, but we divide by, right, exactly. So we divide by 6 to remove the dependence on where at the table you are. The, let's say, seat dependence. So this gives us our total answer, 6 factorial divided by 6 minus 2 factorial, 2 times 5 factorial divided by 5. This was C. Which again, most of the class said, which is pretty awesome. Right? So that one's a little bit, you can see that one's a little bit more involved, right? There are some parts to that, but the hope is that you can kind of like just break it down, right? And kind of think about each of these parts separately, break it down into a bunch of smaller problems, and then just kind of rebuild it back up from there. Where the 6 factorial, okay, sure. So I got a direct message saying, can you explain where the 6 factorial came from? So the 6 factorial comes from the fact that, again, we got 6 people, right? So we've got Tyler, we've got TJ, we've got Asan, we've got Jordan, we've got Aziz, and we've got Parker. And we've got these like 6 seats. This is not a great hexagon. All right, so we've got 6 seats. So I'm trying to figure out who should sit in this seat. And I've got 6 options, right? So there's 6 choices for people who could go here. I'm trying to figure out who could sit here. If you chose me to sit here, I can't also sit in the next seat, right? So there's only 5 people who can sit here. There's 4 people who can sit here, 3 who can sit here, 2 who can sit here, 1 who can sit here. So that gives us 6 factorial ways of seating someone. Yeah. No problem. Aziz, I know you're going to run.
I was about to say that right now.
Yeah.
Just beat me to it. Okay, I'm going to head out here.
Sure. See you later, Ben.
Bye, everyone.
Anyone else? Anyone else? Any questions about this one? Because this is a tricky one. So, if you have questions, that's totally okay. But let me know so we can try and clear some stuff up. Because there are a couple of things that work here, right? This is a compound problem. It has multiple different things inside of here. Everyone's okay? We divide by 6 because we rotate. If we rotate the seam, it's the same. And yeah, and Christian, that's the answer. So here, let me show you explicitly. Let me number us all, okay? Because I don't want to write our name. No, okay, you know what? Let's just write it out. So for example, here's Tyler, here's TJ, here's Asan, here's Jordan, here's Aziz, and here's Parker. Okay, so this is a configuration, right, Christian? Now, what if I rotate everyone by one chair? TJ, Asan, Jordan, Aziz, and Parker. These are the same, right? Because we all are still in the same order, even though we've all moved chairs. And we're saying, like, we don't care where at the table I sit. We only kind of care about the order that we're sitting around, right? So that's the same. And same thing, I can move everyone down a chair again. Tyler, TJ, Asan, Jordan, Aziz, and Parker, right? So we're saying all three of these are the same. And so what you're trying to do is you're trying to figure out, well, how many times did I count this configuration? And you say, oh, well, there's 6 of these configurations, right? One where I sit here, 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 and one where I sit here. And, assume, again, TJ is to my right, Asan is to his right, Jordan's to his right, and so on and so forth. So I've counted this configuration 6 times, depending on which chair I'm in. And we want to say, no, I've overcounted therefore 6 times. So I'm going to divide my answer by 6 to get my final answer. Does that make sense, Christian? Okay, cool. Why we multiply by 2? For sure. Okay. So again, when we were multiplying by 2, we had Asan and Aziz together, right? So Asan and Aziz, we were counting these 2 as a single unit, right? And then let's fill in everyone else. So let's say we had like TJ here, me here, and then Parker and Jordan, right? Okay, now in practice, so we treated this as just being one thing, right? But the problem is that this isn't just one thing. There's actually 2 configurations here, right? One where we have Asan and Aziz like this, and then the other one is where they switch spots. Right? So when we treated them as a single unit, we didn't account for the fact of who was sitting on the left, right? So in one case, Asan could sit on the left. In the other case, Aziz could sit on the left. So when we treated this as a single unit, we actually undercounted. We need to count each of them an additional 2 times, depending on who's sitting in which spot. Does that make sense? Right? Like once we decided that they were going to sit in these 2 chairs, we then had to decide who was actually going to sit in which of those 2 chairs. Yeah, cool. I'm going to interpret that as yes factorial. Okay, and is anyone else? Is everyone okay with this? Can we say that besides Aziz and Asan, there are only 4 people moving as the alternative? Thus, 4 fact. Oh, that's an interesting way of doing that. Okay, sure. So let's think about this. So you're going to say, like, listen, it doesn't matter where they are around the table. So let's put Asan and Aziz in the first chair, right? It doesn't matter what that chair is. That's where they are. And then we've got 4 other people, and we want to move them around. So you're going to do 4 factorial times 2 to get that. Yeah, you could think about it that way. I think, Connie, that's actually a great way of doing it. And you're saying in that like implicitly, you're not having to divide by 5 because you've just said already, I don't care about the order, only the relative order, right? Like you're just saying, I need to now just figure out as I go around where the other people are sitting. Absolutely, you could do that. And that's a great way of thinking about it if you want to. And that is because we see that, right? We see that should come in. The equivalent, same thing when you're doing 6 factorial divided by 6, we all know that's 5 factorial, right? And so what this is the same thing as doing is saying, okay, let's say, and I'm going to choose myself, right? Once we specify where I sit, the only thing that matters is the order of everyone relative to me, right? So we fix where I am. Let's say I'm sitting at the top. Now the only thing that matters is the order of everyone else, right? Once we've determined where I am. And there are 5 people, there are 5 seats, that gives 5 factorial. So totally you could do it that way as well. I think that's a really clever and great way of doing that. Are there any questions related to what we discussed today on the assignment? Because I did A5 without anything we covered today. Well, no, I mean, certainly A5's cutoff would have been Friday, right? So it would have, the cutoff for it would have been last week's material. So I wouldn't have, and that's always true of every assignment, right? I would never require you to use this week's material on an assignment due this week. Because what if we didn't cover it until today, right? Then you'd only have 1 day to use it before your assignment is due. So the cutoff for everything, tests, assignments, is always the week before. Yeah, exactly. Exactly. What we're doing for today is for assignment 6, which is up, by the way, right? It was posted yesterday. And yeah, it's very similar to this. Exactly. It's very similar to the things that we did today. It again uses a deck of cards, but it's a weird deck, right? We added a suit and we added a rank. So again, especially if you don't feel comfortable with cards, you might want to start it a little bit earlier just to think about it a little bit and make sure you're okay with it. Okay. Everyone, if you can, just give me a couple minutes here. Let me go like refill my drinks and everything, and I'll come right back and then I'll answer any and every question that you have. Okay, so give me 2 or 3 minutes. Can we go through card problems in the textbook later? Yeah, sure, absolutely, we can do that. Okay, so just give me 1 second, I'll be right back. Okay, I am back. Sure. So Connie, if you don't mind, let me just do Dowd's problem first because it's kind of related to the assignment. I suspect there might be some people here who kind of like worried about that. When we say describe sets, what we mean is just basically use words to describe what would be in them. So kind of, again, let me kind of pull on examples that we've done previously. So let's let Z be everyone in the Zoom meeting. Everyone in the Zoom meeting, right? Let's let B be the blonde students. And I don't know, let's choose something else. what do we want? What do we want? Let's let T be the tall students. Let's say the students who are bigger than, let's say 180 centimeters, right? Whatever that is. So are we asked to calculate the number of the songs about love without anything else? I mean, you have to, yeah, I mean, I'll have to look at it, but let me answer this question or do an example of this first, and then I'll see if I can answer that. So you could be asked, for example, to describe this set. Let's do BC intersect T, right? So our question could be something like describe this set, right? So you all tell me, what is this set? Like, you could do it in set builder. So it's the people in the Zoom meeting such that what? Like what? They're not blonde and they're tall. Exactly, right? So they're not blonde and they're taller than 180 centimeters, right? Right? Or we do something like B intersect T complement. Okay, what would this be? So people in the Zoom meeting okay, and there's a couple of answers to this one. So let's not, I know that some of you know how to go straight to the final answer, but let's just kind of parse this off at one at a time, right? So we've got this complement here. So we want the people who are not B and T, right? Exactly. So not blonde. Well, hold on, let's be careful. So not blonde and tall, right? So let's be careful about where the blonde or where the and is there, right? We do have to be a little bit careful. And normally in language, you don't worry much about this. And Christian, exactly, you have the, again, we want to be careful because I know what you're saying. You're saying not blonde or not tall, I think is what you're saying, right? But we have to be careful because in language, I know that you meant to include the not with the tall, but right, like your blonde or tall is a thing, but we have to be a little bit careful when we're doing mathematics. We really want to be precise. So we want to say it's the same thing as saying that the people that are not blonde and tall, right? So what I want you to do is actually think about who are the people who are not blonde or tall. They are either the people who are not blonde or they are the people who are not tall, right? Right. Not blonde or P is not tall, right? Because one of them requires you to be both. So to not be both, you could still be one or the other, right? You could be blonde but short. That's okay. That's allowed because blonde short people are not blonde and tall, right? And so that's what I'm saying. We just have to be a little bit careful about where those ands and ors and where the nots fall into that. But this would be the description of B intersect T all complemented. It's the collection of people who aren't blonde and are not tall. And in fact, we could kind of go one step further if we said not tall is maybe the same thing as short. Like, I don't necessarily think that's true, but you could be like, they're the short, not blonde people or something like that, right? So Doug, does this make sense about in terms of like describing the set? So you really want to take what does intersection mean? What do union mean? What does the complement mean? And then write that out using your description of your set. So in the case of the assignment, D, E, and F are love, prison, trucks, whatever, and then translate what those words mean into love, prison, and trucks. Like what set operations? Like, what do you, can you be more specific? And while you're doing that, so Connie said for question 1, are we asked to calculate the number of songs about love without anything else? So let's be very precise. It says the songs that are about love, but not about trucks or prison. That's not necessarily the songs that are only about love. Yeah, those technically could be different things. Okay, so like we really have to think about exactly what the question is saying. It's saying the set of songs that are about love but are not about trucks or prison, right? Could you be about love and not be about trucks or prison, but also be talking about other things? Theoretically, that is possible, right? Like, what if we said there was a fourth set, G, which is the songs about partying, and we just didn't include them because there weren't enough of them. So maybe there's a set G, which is the songs about partying. And are there songs about love and partying? Yeah, sure, totally. But that's not, yeah, exactly. Yeah, exactly. So do you know what I mean by, like, we have to be careful about what we mean by only love, right? There could be about other things that just aren't classified as trucks or prison, because there's more. In fact, if you look at question 2, if you've answered question 2 yet, you'll realize there are some songs, I don't mind spoiling this because I'm not going to tell you what the number is. There are some songs that are not in D or in E or in F, right? There are some songs that were surveyed that are not about any of these three things. And that's what you're doing in part 2. So that's kind of the thing to keep in mind, right? You should use the set operations to help justify what it is that you're doing, right? So in part 1, for example, you know what the songs about love are, you know what that set is called, you know what the songs about trucks are, you know what the set about prisons are. So use the set operations to write that set down in terms of D, E, and F, unions, intersections, set subtractions, complements, these sorts of things, right? So in part 1, that's what it means by use the set operations to write down. Basically, part 1 is, this is the description, write it as a set, right? And part 3 and part 2 are the opposite, right? This is a set, give us its description. And do you mean like marking? I don't remember. I'd have to look. I've got a big list somewhere of all the TAs and which assignments they're marked assigned to. I don't think Aziz is doing it though. He's finished his marking for the year. So Dad, can you be more specific about like what set operations you're talking about? And then Brandon, I'm reading your message now. Yeah, Brandon, I think that's a perfectly fine answer. Yeah. As long, again, you should explain what your illegal combinations are, but as long as you've done that, that's okay. Okay, did I answer all the questions about this? Because Dowd, I don't know. I haven't heard from you for a bit. Well, no, okay, so the D is 47 songs, are those 47 songs that are about love, but those include the songs that are about love and trucks, right? So a song that is about love and trucks is also a song about love. So when we say that the number of things in D is 47, we're saying that includes also the songs that are about love and trucks, the songs that are about love and prison, the songs that are about love and trucks and prison, right? And then part 1 doesn't want that though. Part 1 wants you to tell me which songs are about love, but not about trucks or prison. It's not even necessarily pure love, Connie. I think you're trying to like use the language, right, in order to figure out what these things are saying. And I would say, yeah, don't use the language. Stick with the math here. And Christian, yeah, I'm going to say your comment out loud because I think it is valuable, that the Venn diagram really helped in this question, right? That making the Venn diagram makes a big difference. Okay. So don't, because Connie, by your thing, we had a bunch of students say like, well, what do I even do in part 2? Isn't this just empty? Like if I take, if you think about what part 2 is asking, they're like, there shouldn't be anything left over. And we said, no, there is, you have to think about it, but there are things left over. So I do want to say, just be careful about what it is you're saying. Don't use the English language to try and interpret this question. Really fall back on the math and rely on what the mathematics is saying. And draw the Venn diagram, right? Draw the Venn diagram, fill in the numbers. It will help a lot. Well, okay, now you really want to be careful about posting that not privately. right? This isn't a big deal. We're not, but just be careful, right? You don't want to give stuff away, right? And also, you probably know, like I won't confirm for you one way or another what the answer is. If you're stuck on something, I'm more than happy to help you, but some students will come up and be like, is this right? And I say, well, it's an assignment question. I'm not going to confirm whether your answer is right or not, but I will help you if you're stuck, and I will point out issues. I think that you're close, but you don't quite have it, right? Think about what the word and means, for example, right? What set of operation is and? Dot, okay, I'm going to read your direct message now. Set. Okay, Connie, give me a second. Let me answer this question here. I'll try and come up with a better example for you. Maybe it'll clear it up for you. Excuse me. So you write down the set, your songs, only about love and not trucks. Okay, so Dot, again, you have to be careful, not and, right? The question says or, right? And those mean different things in the mathematical context, right? And or are very different. But yes, that is what we want if you fix and to or. Okay, cool. So Connie, let me say the following. Okay, so we've got blonde students, we've got tall students. Let's say the guys in the class. Okay, G are the set of people who are identify as being male, right? Let's say M. So these are the male students. Okay, and I could say to you something like, describe for me how many students in this class are male but not blonde or tall, right? And you're asking me, oh, does that mean that I'm only after the male students, right? Like the students that are purely male? And I'm saying, well, no, because being blonde or tall, like, students can be more than male, blonde, or tall. Do you know what I mean? Like, there are other things that people can be. Does that make sense? Right? If I said, describe for me male students who are not blonde or tall. Well, there could be people, because exactly, people can match multiple physical characteristics. Exactly. So there could be people who are male, short, and black hair, or male, short, and red hair, right? There are multiple characteristics there that they can match. It's not like we can't just say, oh, if I throw out all the blonde people and all the tall people, then we're looking for short men who are black haired, right? Does that make sense? Like, this is not the same thing as short males with black hair. Because there could be short males with blue hair. There could be short males with brown hair, with blue hair, with red hair. There are other things that could be satisfied here, right? So if we throw out all the blonde men, then, well, there are other things, right? They're not just black-haired men. There could be other stuff. So does that make sense, Connie? Like, when I say look for this, I'm saying really look for that. Don't try and translate this into some other sentence, right? Just, you have to read what it's saying and really take it at face value here. Have you drawn the Venn diagram? Have you drawn it? Okay. So have you written this as a set now? Like what you're looking for, this love, but not about trucks or prison? Send it to me in a direct message, right? So what you did before was close, but was not right. Okay, great. Well, what is the math symbol for or? No. Think of the set operations. What's the set operation for or? Right. Okay. Right. Exactly. A no, other one. Okay. So, Connie, could you draw for me your thing? Here, let me just, I want to send. Could you draw for me? Like, don't actually do it, but could you draw this in your Venn diagram? Like, fill it in. And because then if you have your Venn diagram, you should know exactly, right? Like you'll shade in that area and you'll know exactly what the numbers are. To some extent, yes. Yes, sure. If you want, I guess, language wise, sure. If you want to say that, I think it's okay. I can't confirm that or deny it, but I think language wise, what you're saying is okay. Yeah. And I think I might be confusing you just because I'm being a little too pedantic, in which case that's my fault. I think you have the right idea. It's just, I'm just trying to tell you that you want to be a little bit more careful, because what I don't want you to do is take the wrong idea from this and then do it on a test or something and then get burned by it like that. Do you know what I'm saying? Like, I just want to make sure that you really understand what it is you're being asked, and to be careful not to use the English language to figure out what's mathematically being said. That's all I want, right? Because I don't want you to come back later and be like, this is what I thought it meant based off of what we did, and then I got a bad mark on a test or something. Okay. So that's just going on there. Right. Okay. I mean, like, here's a helpful, that the intersection sign kind of looks like an A, right? So B and T, this kind of looks like B, A, T, which would be like and, right? B and T. So I think that might help. And again, right, this means the intersection of blonde and tall, so B intersect T, says you have to be both blonde and tall, right? But the union only says you have to be blonde or tall. You could be both, but you only have to be one of them, right? So that's why it's an or statement. This is the number. Connie, use brackets here because I'm not certain what the order of operations is in this. Complement does uses and, right? It depends what you mean. So if you take the complement of an intersection, this is true. And then if you take the complement of a union, this is true as well. And you can check this using a Venn diagram. So the complement flips and union and intersection, if that's what you mean. Yeah, Jack, exactly. And by everything in each, you mean everything in both of them combined. Yeah, everyone, I don't want to be pedantic because I think I am starting to confuse some of you. So question one, part one, I think you do have all the right ideas. It's just I don't want to throw you off too much. It's just you have to be careful what you mean when you say it's purely about love, right? But you all have the right idea, right? You just don't want to say is only about love because that's not a true statement, right? They could be about other things that aren't mentioned as being one of D, E, or F, right? Which is what I'm saying about the pedantry, right? It's a pedantic answer, but it is an answer we have to be careful about because this is a fallacy, right? It is the law of the excluded middle, or the fallacy of the excluded middle. Sure. I mean, like, I'm not gonna, like usual, right? I can't confirm an answer, but let me take a look at, you just had to put that one sideways for me, didn't you? Did you write that on a napkin? Right. Yes, Connie. Yeah, that's what you want. Okay. So Connie, yes, what you want is that. Brandon, yes. Yeah, the issue isn't saying that they all have to be in D. They certainly have to be in D because they're about love, but you can't say that they're only about love. Okay, that is not a fair thing to say. Okay, is everyone all right? Connie, are you okay? What do you mean D and E works? I don't know what that means. Again, you have to be precise here, right? Because here the language is starting to become very careful. So we need to be very careful about it. Yeah, okay. Here, let me just answer this. I don't know what you mean by it doesn't work though. Or I don't know what you mean by works, Connie. That's kind of the issue. Like D and E and F is a thing, right? You can compute the size of it, but does that mean work or not? Like, I want to know very precisely what you're saying because I don't want to tell you the wrong thing. Brandon, again, let me think about it. If I said, tell me, okay, let's go back to our example up here. Let's not even worry about tall. If I said, count for me, included in the answer we are looking for. I mean, you want to throw those things out, right? You don't want D and E because E is stuff about trucks, right? So you're trying to get rid of the stuff about trucks. So you don't want any truck stuff, right? You're going to get rid of it. Okay, good. No problem. So Brandon, if I said, tell me about all the males in the class who are not blonde. If I said, count all the men in the class who are not blonde, and you say, oh, so I only want black-haired men. And I'm saying, no, that's not what I asked you to compute. Right? So if here are the men in the class, here are the blonde people in the class, and I said, find the men who are not blonde, you're looking for this, right? But you can't say that those are the black-haired men because there are men in here that are not black-haired and not blonde. Does that make sense, Brandon? Yes, it's just that it's, and again, I'm kind of starting to regret this because I think I've just confused the point. You are looking for the right thing, right? You're looking for the thing that I've shaded in when I say find the men who are not blonde. But what I'm saying is you can't say in English that men who are not blonde are black-haired men. That's not a true sentence, right? So you can't say, oh, I'm just going to find all the black-haired men. That's the shaded area. That's not true. Okay, there are men in here who are not black-haired and not blonde, right? There might be a separate set that we don't know about. So you can't say, right? Like maybe these are all the red-haired people. So you can't say that the shaded stuff is just the black-haired men. That's not true. It doesn't change what you're trying to find. I think you all know what it is you're trying to find, right? You all have the correctly shaded area, but you can't say that these are only the black-haired men. That would be a wrong sentence and you would lose a mark for it. Yeah, right? There is an excluded case, right? Like there, and you don't care about it. It doesn't affect your computation, but it is a wrong sentence, right? You can't just say throw away the red-haired men, right? Because you would get a different answer. So you're all computing the right thing, but I think that you're saying the wrong things, right? Theodore, I haven't gotten to yours yet, so I'm not certain if what I'm saying is addressing your thing or not. Okay, but Brandon, is that okay? Does that make sense? It's a language thing. I'm saying you can't say those words. That sentence is not true. You're still computing the right thing, but your sentence is not right. Okay, so Connie, yeah, you're saying you understand what I was saying too, when I was saying like you can't say that. You can't say that those are songs only about love. You were computing the right thing, but you can't say they were only about love. That is a wrong sentence, right? Because it could have been about other things. It could have been about a party, right? As well. It was kind of like red-haired people here. Right, exactly. Yeah. Yeah, Brandon. Okay. Okay, Theodora, let me read what you said. And Christian, I've seen yours as well. I'll get to it. I'm sorry. Yeah. So Theodore, do you understand? Yeah, okay. So I see now that what I was saying, I think does actually fit your question as well. So yeah, no, it's okay. It's okay. Did I clear it up at all, or are you still bothered by it? Like it's the word only here is the problem, right? Okay, cool. Yeah, because everyone, I think this is the issue. The issue is the word only. Because when we say only about love, we mean only about love in the context of trucks in prison, right? So if you get rid of trucks in prison, you're right. It's only about love in the sense that there are no trucks or prison involved. But there could be other things, right? Exactly. There could be other subgenres, right? Or other things that the song is talking about that isn't one of these three. Exactly. And you can't say that it's only about love and not about anything else. It's just that it's not about trucks in prison. Exactly, Theodore. So you have exactly the right idea. Yeah. And again, everyone, I know that probably sounds super pedantic and you're like, who the hell cares? Like, that's not like, I can draw the picture and I understand what's going on. But the thing is, mathematically, you have to be precise about these things because it's really easy to make that sort of wrong assumption and it lead to you getting the wrong answer. Okay, it won't lead to you getting the wrong answer in this case, but it can lead to a wrong answer. And I've seen like senior undergraduate students make this mistake. Okay, so we have to be careful about that. Brandon, I would love to answer that question, but I have a queue and I want to get to it. So if there's free time, I will talk to you forever about what 102 is, but let me try and get some of these out of the way. Christian, I'm just getting to yours now. I'm sorry that took a couple minutes. So in our answer part one, right. Yes, Christian, exactly. Okay, so Christian, you're good? Yeah, you have, yeah, you described it perfectly, basically, right? That is exactly the right answer. I did a whole page and paragraph for question two. Is it enough? Yeah, I think that's fine. I mean, Connie, what I'd like is, ideally, hopefully you separated and you said, here's, I'm going to count XX, here's I'm counting N, here's I'm counting TTT and all that. And then, a couple of sentences describing how you counted each of those, that's totally fine. Just so long as, it's formatted quite nicely, so that the TAs can look at it really, really quickly. Yeah, totally cool. That's totally fine. It's allowed to be a little bit long. That's all right. And for question 2, yeah, exactly, Connie. Perfect. Have the possibility of only one digit of 1 and having. If we account for both, like, do we add the possibility of having only one? Yeah, okay, so in YYY, they're not allowed to be beside each other. So this is why I gave this example. If I'm understanding in your question correctly, like 181 is allowed, right? This is legal. It does have 2 1s, but they're not beside each other. So the issue is only if the 1s touch each other, right? So this is okay. 117, this is bad, right? 611, that's bad. 111, that's bad, right? So none of those are allowed. But the 1s, you can have 2 1s so long as they're not touching each other. So let me reread your question again and make sure I think I got it right. I'm asking if we account for both, right? Yes, right? So you said we have the possibility of having 1 digit be a 1, that is allowed. Oh, and by the way, not all digits have to be 1, right? Like 768 is also a totally valid combination, or 430 is a valid combination, right? It doesn't say there has to be a 1 anywhere, just that if there are 1s, they can't be beside each other. Okay, so you're good? Does that make sense? Jack, you need compliments on D, E, and F. Okay, Aiden, perfect. Oh, and sorry, Brandon, I thought you just said, what is Math 102 about? Not, is this what Math 102 about? No, Math 102 is not about anything like this. Math 102 is a lot of fun, but you'll see one day. And then you'll be like, he said this was fun. He lied to me or something like that. Okay, is everyone okay? Connie wanted to do a card question, and then I think Brandon wants to talk about 102. Is everyone okay with this? All right. Connie, do you have, can we do 4-4? Oh, I was going to ask if someone had one. So yeah, perfect. Let's do that. Sure. Yeah, I mean, no, this sort of stuff doesn't, I mean, set operations do come in. So Brandon, these sorts of things, we're just kind of like assuming that these are true, but in Math 102, you would prove this. Right? Like you would be required to demonstrate that this was always, oh, to pedantics? Yes, it's very pedantic. Because it has to be, right? So Brandon, here's a question that I want you to think about. Is it true that every person standing on the moon right now has black hair? Sure. Is that sentence true, though? Is the sentence that I just said to you a correct statement? Oh, we are split. We are split. Why wouldn't it be true? Yeah, sure. It's not false. No, it's a true statement. It absolutely is a true statement. Mm-hmm. Okay, because here's the negation of that sentence. So every sentence, either if I give you a statement, either it or its negation is true. Does everyone agree? Like if I said, if I said the sky is blue, or if I said the sky is not blue, one of those sentences is correct, right? They have to be, because one is the statement and the other is the negation of that statement. So one of those statements has to be correct. Do you agree? Okay. And that's always true, right? If I said 7 plus 7 is 12, or 7 plus 7 is not 12, one of those sentences is correct, right? It's the second sentence, but one of those sentences is correct. Okay. Every person standing on the moon is blonde. The negation of that sentence is there's someone standing on the moon who is not blonde. Which of those statements is correct? Or maybe the better question is, which one of those statements is for sure false? Right. Okay. There is someone on the moon right now who is not, did I say blonde or black haired originally? Black hair? Black. Okay. There is someone standing on the moon right now whose hair is not black. Is that statement correct? No, that statement is objectively false, right? There's nobody standing on the moon. So if I said there's somebody on the moon who satisfies this property, that is a false sentence, right? Because there's nobody on the moon, right? So it doesn't matter what else comes after. The moment I say there's somebody standing on the moon, it's wrong, right? So that sentence is false. Therefore, its negation, every person standing on the moon has blonde hair, is a true statement because there's nobody standing on the moon and they all have blonde hair, right? Every person standing on the moon right now has blonde hair, right? Because its negation is false. So it must be a true statement. Right? So do you see about the pedantry of like, if I proceed to say for every X in the empty set, anything is true. Every statement about a point in the empty set is a true statement. Right? If I say every person standing on the moon is 100 feet tall, that is a correct statement because it is true for every person standing on the moon, right? Give me a counterexample. Give me somebody standing on the moon who's not 100 feet tall. You can't do it. So it must be a true statement, right? If my statement was false, you'd be able to give me a counterexample, right? You'd be able to say, no, here is a person standing on the moon who is not 100 feet tall, right? So yeah, this is the sort of thing that you might do in Math 102. And you can see that, yeah, there's some pedantry here. And you do have to be careful because these things come up, right? These things do come up mathematically, and you need to know, yeah, you have to know how to deal with them. And Math 102 is actually a lot of fun. It is a little bit hard, but it is a lot of fun. And you'll get to learn lots of cool words and things and math, right? So yeah, it's definitely a lot of fun. And if you want to, I have Math 102 notes on my website. So if you Google my name, you can find my Math 102 notes and you can get an idea about it. I think 102 needs a lot of work. I think it needs to be fixed a bit, but like, if you want to get a look at the way it is currently, you can go look at my notes. Okay, so somebody wanted 4-4. So let's take a look at that. Let's try and see if we can get one of these out of the way before office hours ends. So this is 4-4. So whoever asked for 4-4, I'm sorry, I don't remember who did. I'll scroll up to see if I can find it. Oh, and Connie, I missed your thing here about why. There's more than that though, Connie. So if we get rid of the possibility of 11 for the first. So because we got, yeah, so Connie, like you're missing some cases. Oh, but maybe your ... dots include them, right? Maybe that's what you're saying. Right, okay, yeah, if your ... dots include where the ones occur at the beginning and where they occur at the end, then yes, that is a correct thing. 4.4-C, okay, sure, let's do C. So C is, it explains, well, that word mark there is kind of weird. So it explains what a full house is. So a full house, for those of you who don't know about cards, a full house is 3 of a kind and then a 2 of a kind, right? So I give an example of this in the thing. So we have, for example, a 10 of hearts a 10 of diamonds, a 10 of clubs, a queen of clubs, and a queen of spades. Okay, so you have 3 of a kind, and then you have a 2 of a kind, right? So so we want to count how many full houses there are in a deck of 52 cards. How many full houses are there? So does anyone have an idea what we should do? There are a couple of different ways to do this. Let's see if we can. So does anyone have, what should we do first? What do you want to do? So count the full houses. Okay, so count, yeah, okay, so you want to count the 3s, is what you're saying, Ariana? Okay, so let's do it. So what do I need if I count the 3s? What's the first thing I should do? Do you want to do rank or do you want to do suit? Okay, rank. Okay, how many ranks are there that I could choose from? Okay, yeah, there's 13. Connie, it's a, right, yeah, sure. Yeah, Connie, yeah, that's right. So 13, perfect. And then, so once we've picked the rank, we need to pick the suit. We need 3 cards, but there's 4 suits. So how many? Exactly, 4 choose 3, perfect. Right, and Connie, that is the same answer as you gave, because your 13 choose 1 is the same as 13, right? Okay. And now, so that you should multiply for sure. Yeah. Okay, so for now the 2 of a kind, how many suits or how many ranks? Let's do rank first. How many ranks are there? 12, right? Exactly, because we can't choose the same rank as before, right? So there's 12. And then how many suits? 4 choose 2, perfect. And then we multiply these and there's our answer. And Connie, yeah, your answer is the same, right? Because 12 choose 1 is 12. Same thing, everyone note as well, what you could have done, which obviously gives you the same answer. I say obviously, but obviously gives you the same answer, is you could have said, I'm going to do 14, pick 2. And this is me picking the ranks. And then I'm going to do 4, choose 3 for the suits of the 3 of a kind. And 4, choose 2 for the suits of 2 of a kind. Why did I use a permutation when I was choosing the ranks? No problem, Brandon. Why didn't I use a combination when I was choosing the ranks? Why did I choose a permutation? Order does matter. Why does it matter? One is a triple and one is a double. Exactly. So if I say whichever rank I choose first is the triple and whichever rank I choose second is the double. So above, what I did was choose 10 queen, right? So because the 10 was the triple and the queen was the double. That's different than a queen 10, right? Because queen says I need 3 of a kind in the queens and 2 of a kind in the 10s. Order matters here, right? Order, so I had to use a permutation. Or sorry, you're right. Yeah, should be 13, my bad. I was thinking about the question on the assignment, but you're right, Connie, thank you. Yeah, it should be 13, choose 2, or pick 2. And of course, 13 pick 2 is what? It's 13 times 12, right? And that is exactly, all right? No problem, Theodore, see you later. So does that make sense? Ariana, does that help? Yeah. And so you do, that sort of stuff. You can do that with 3 of a kind as well. You can do it with 2. And I think even, yeah, in 4-5, we talk about straights and flushes and straight flushes. The cards are a good example. I really recommend going through 4-4 and 4-5. And I don't remember if I have the solutions online for this one. But these are easy ones to Google because these are standard hands. So if you just Google how many full houses are there in a standard deck, you'll find like a YouTube video of someone doing this as well. So if you really want a solution that way, you could do it as well. So I recommend you practice them, try and do them on your own. And then if you really get stuck, obviously ask us. I'm not trying to push you off into like YouTube or something, but if you don't want to, almost certainly you can find a YouTube video or something like that explaining it, because these are standard sorts of counting problems. And yeah, there's lots of poker sharks in the world for whom this actually matters, right? In fact, if you're trying to figure out why the poker hands are ranked the way they are, right? Like why is a flush higher than a straight? It's because when you do the counting, what you'll realize is there are fewer flushes than there are straights, right? And that's why a flush is a higher ranked hand. So if you go through and you compute the number of every poker hand that occurs, you'll find that they get fewer and fewer and fewer as you go, right? Which is how it should be. Okay. So it's 7 o'clock now, everyone. If there's any like quick last minute questions, I'm kind of happy to take them up. Otherwise, I think we're good for this week, and we can probably kick back and relax. Thank you, Aiden. See you later. No problem. Yeah, they're definitely worth doing, Ariana. I hope you give them a shot. Okay, no problem. Thanks, everyone. You too, Brandon. Have a good weekend, everyone. I'll see you all next week on Tuesday. Ciao.